This is the 21st video in my series on three-phase power transformers. In this video, we'll be looking at the various types of cooling systems used within power transformers. As before, this is an excerpt from my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my StanStore at this web address. AN, air natural, cooling of a transformer. These transformers are cooled with the ambient air. The natural convection of the air removes the heat generated by these transformers. The symbol for this type of cooling is A, N, and is normally stamped on the nameplate. ONAN, oil natural air natural cooling of transformers. This is one of the simplest transformer cooling system there is. Here, the natural convectional flow of hot oil is utilized for cooling. The oil will absorb the heat from the transformer windings and core and is then migrated to the top of the transformer. It will then circulate naturally into the radiators, which will dissipate the heat into the atmosphere by natural conduction and radiation, thereby cooling. The oil then moves to the bottom of the rads and tank to start the process over again. In this way, the oil in the transformer tank continually circulates when the transformer is under load. As the rate of dissipation of the heat of the air depends upon the surface of the oil tank, it is essential to increase the effective surface area of the tank. So, additional dissipating surfaces in the form of tubes or radiators are connected to the transformer. ONAF, cooling of transformers, which stands for oil natural air forced. Heat dissipation can obviously be increased if the dissipating surface is increased, but it can be made further and faster by applying forced air to flow over the dissipating surfaces. Fans blowing air on the cooling surfaces is employed. Forced air takes away the heat from the surface of the radiators and provides better cooling than just natural air convection. As the heat dissipation rate is faster, electrical power transformers can be loaded more without crossing the permissible temperature limits. The air forcing fans are sometimes switched on and off in stages, providing stage ratings for the transformer. The heat dissipation rate can still be increased further if this oil circulation is accelerated by applying some force. In OFAF cooling systems, the oil is forced to circulate within the closed loop of the transformer tank by means of oil pumps. OFAF means oil forced, air forced cooling methods of transformers. The main advantage of this system is that it is compact, and for the same cooling capacities, OFAF occupies much less space. We know that ambient temperature of water is much less than atmospheric air in the same weather conditions, so water may be used as a better heat exchanger medium than air. And that is especially true if there is plenty of water available, which is the case for hydraulic generating stations. So quite often in some of the larger hydraulic generating stations, transformers, as well as some of the generators, have water-cooled radiators that dissipate the temperature away from the equipment. In OFWF cooling systems of transformers, the hot oil is sent to oil to water heat exchanger by means of oil pumps, and there the oil is cooled by circulating cold water on the heat exchanger oil pipes. OFWF means oil forced, water forced cooling in transformers. Liquid-cooled transformers. These transformers have coils immersed in insulating medium, usually oil, which serves multiple purposes. First, to act as an insulator, and second, to provide a good medium through which to remove the heat. Liquid-cooled transformers cooling classes went through a major change when the IEEE adopted the standard of a 4-letter designation found on most modern power transformers. The first of these 4 letters designates the internal cooling medium in contact with the windings. O stands for mineral oil or synthetic insulating liquid with a fire point of less than 300 degrees C. K stands for insulating liquid with a fire point of greater than 300 degrees C, and L is insulating liquid with no measurable fire point. The second letter designates the circulation mechanism for internal cooling mediums. N stands for natural convection flow through cooling equipment and windings. F is forced circulating through cooling equipment such as cooling pumps, and uses also natural flow of convection of the windings themselves and isn't necessarily directed. The D is the directed element. It actually stands for force circulating through cooling equipment that is directed from the cooling equipment into at least the main windings. The third letter stands for describes the external cooling medium. A for air, W for water. The fourth letter stands for the circulation mechanism for external cooling medium. N for natural convection, F for forced circulation, such as fans and pumps. Here's an example of what you might find stamped on a transformer, ONAF, which stands for oil, natural, air, forced. ONAN stands for oil, natural, air, natural. And OFAF, cooling of transformers, stands for oil forced, air forced. And OFWF stands for oil forced, water forced. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂 products, check into this website to browse the full extent of their products. There is no cost or commitment for viewing. Before ending this video, let me repeat the connection to obtain my free copy of the Ultimate Guide to Residential Standby Generators and receive access to all of 𝐃𝐈𝐒𝐂 products. Also, here is the connection to obtain a free copy of my 50-page electrical power crib sheets. And finally, here is a link to all of my electrical courses, which are located in my stand store.